All right, guys, do now. Okay, so Erica, when you open up your notes, since you've already opened them up, you would open them up from your drive. Okay, because every time you open up from Google Classroom, it's going to create a new copy. For those of you that haven't opened them yet, you will open them up from Google Classroom. So it should be a couple things down in the feed, because I did post it on Tuesday. All right, so just copy down your homework. Earth Layers worksheet is CAMI assignment posted on Google Classroom. Is everybody there? Yes? No? Okay. All right, so some of this is going to sound foreign to you guys. Erica, this will sound familiar.
What they've learned is that the Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which consists of rocky material so hot and under such great pressure it is in a liquid state. The mantle, which is not quite so hot as the outer core and not so liquid. No one has ever seen the mantle, but scientists believe mantle material may resemble lava which erupts from volcanoes. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere.
All right, so again, just to review, there are 4 layers of the Earth. You have the crust, which we are on, right? You have the mantle, which is underneath. The next layer below that would be the outer core, which is the only truly liquid layer of the planet. Now, the crust and the mantle, again, are made up of rock. Crust is solid rock, mantle is soft rock. Outer core, liquid metal, that being iron and nickel. Inner core being a solid ball of metal, also made up of iron and nickel. Now, when you take the crust and then the uppermost part of the mantle, right? Because the uppermost part of the mantle is still basically solid. Combine them together. What did they say that, what layer that made up on the video? Begins with an L. It was one of the last things they said on the video. Lithosphere. All right, so we're going to talk about the individual layers. We're going to start off with the crust. All right, so it is made up of solid rock. Uppermost layer. It is thinnest of all layers, and I'll give you an example, an analogy for that in a moment. Now, again, just a reminder, when you're done copying down the slide, please close your Chromebooks halfway. That way, when everybody is halfway closed, I know I can move on. Yes, you can. All right, so everybody's seen an apple before, right? So when you cut open an apple, cut an apple in half, right, and you're looking at one of the halves, right? You see how thin that apple peel is, right? That's basically a good analogy to the structure of Earth, because the crust of the Earth would be like the peel of an apple. Now, you have the white fleshy part of the apple, right? That would be the mantle. And then the inner part where the seeds are would be called the, what do you call that in the center of the apple where the seeds are? Core. All right. And basically that would be a good representation of the size of the different layers of the planet. Now, the crust can be 24 miles up to 75 miles thick under the continents. Oceanic crust is much thinner. Now, continental crust is made up of the rock granite, continents being solid land, which we're on now. And then oceanic crust is much thinner. It is made up of a rock called basalt, but it's more dense. Even though it's thinner, it's more dense. And the idea of the oceanic crust being more dense is going to play an important role in our next topic when we talk about plate tectonics. So again, if you're done copying, make sure your Chromebook is closed as well. Are you having trouble seeing? Look. Did you get all this down or no? Did you also complete the Google form from yesterday? The Google form. The exit ticket. Yeah. Okay. We good? Frankie, you done? Okay. Another quick short video clip.
Earth is made of layers. A thin coat of soil and water sit like makeup on the top layer, which we call the crust. You can dig down through soil only a short distance, perhaps less than half the length of a soccer field, before hitting the crust, which is a shell of rock surrounding the entire planet. Like a slightly damaged eggshell, the crust is cracked. It's in about 20 pieces, which we call plates. The plates come in two varieties, ocean plates and continental plates. Ocean plates are about 5 miles or 8 kilometers thick. Continental plates are many times thicker, but the rock is lighter in weight. Where ocean and continental plates overlap, continental plates usually ride on top, like oil on water. Going through Earth's rock crust is tough work. The world's best miners have been able to go down only about 2 miles or 3 kilometers. Toward the bottom of these mines, a surprising thing happens. The crust gets warm. In fact, the mines need air conditioning. Deeper inside Earth, temperatures climb thousands of degrees. On the surface, we don't feel this heat because the crust protects us from it. Why is it so hot inside Earth? Geologists list 2 main reasons. First, Earth formed long ago through a series of fiery collisions of tiny hot planets. Some of that early heat still remains. Second, new heat is created inside Earth through a process called radioactive decay. Together, radioactive decay and early heat make the inside of the Earth up to 20 times hotter than the hottest kitchen oven.
Radioactive decay, basically just nuclear reactions occurring inside the planet. All right, so again, they mentioned something in the video about the outer shell of the Earth. Now, again, the outer shell is not just the crust, but the upper part of the mantle, right? Because the upper solid part of the mantle together, they make up the lithosphere. Now, they said that the lithosphere, did they say that it was one solid piece around the entire planet? What did they say about the structure of the lithosphere? It was broken up into 20 separate sections called plates, right? And we have 2 types of plates. What are those 2 types of plates? Well, think about the 2 types of crust I just talked about before. Remember, one was made up of basalt, one was made up of granite. We have continental plates, and we have oceanic plates. Oceanic plates, obviously, ocean floor. Continental plates, solid land. All right, so a couple things. Can anybody tell me what the word hydro means? What does the word hydro mean? What does hydration mean? Nobody can tell me what hydration means? Nobody plays a sport? Hydro means water. All right. What does the word sphere mean? Circle, round, right? So if I take those 2 words and combine them, hydrosphere, then I'm talking about a circle of water, right? So the hydrosphere would be all the water that's on the surface of this planet. That would be your lakes, rivers, oceans, glaciers, all right? All that combined would make up the Earth's hydrosphere. Copy these down, please. So again, as we pointed out before, as it was pointed out in the video, crust and upper mantle make up the outer shell called the lithosphere. You really definitely going to need to know that term, hydrosphere. They will both be on next week's test. And everything that's included in the hydrosphere, like I just went over. And because of the increased temperatures, as you get below the crust, that's going to heat the rock up to a point where the rock becomes soft, almost like tar-like. Now, I know you guys, some of you didn't watch Tuesday's video, so the example I used of what the material of the mantle is like, it's like this slime here. All right, malleable. All right, so we've referred to that as a semi-solid. It is not solid, nor is it a liquid.
But if you do it that way, does it have to be already like under candy?
Well, I know that
Instead of opening it up and then you have to open it up, but like it doesn't have to be like into the candy program. It's like the other direction over here, keep down there.
So what I did is
Maybe it makes it so they don't have to open it.
no, because when I try to open it, still,
You still have
right, like,
you still have nothing on it. You still have nothing on it. Yeah, 'cause I always just do the other way. And that was right. See, and yeah, right, yeah.
that's a problem.
But if we just, like, say, I just, like, so you limit it to a Google Slides for a few people kids, right?
Yeah, but this is on notebook.
But if you share the notebook slides, and they don't.
They should be
They're able to open
They
it.
should be able to now. When you go to the smart website, they actually, like, I opened up one of my presentations on their website, and it actually has a PIN number. So I'm assuming that's for them to join.
I gotta start using my old slides again, especially for the kids at home, and I have them. Instead of just giving them generic. It's the videos I show in class, and the kids can watch.
I'll try to figure it out. So I'm assuming everybody's done with the first two, right? So I can close them up. Who's still working on 3? Okay. All right. Again, another thing that we went over yesterday is we talked about the 3 things that change as you go from the crust to the core. All right. So as we go deeper into the earth, 3 things are going to increase. Your temperature, obviously, we've just learned that, right? Pressure also increases, because that makes sense, because, again, if you've ever gone swimming and you swim to the bottom of the deep end in the swimming pool, you can feel the pressure change, the increase in pressure on your ears. And then there's an increase in density. All right. So 3 things increase as you go from here to the center of the planet: temperature, pressure, and density. Are you good on 3? So it also says that the lithosphere becomes softer and flows. It literally flows. And you guys see magma, right? Lava, right? That's what they're talking about.
miles or 45 kilometers down, the temperature is high enough to melt rock slightly, to make it soft and gooey. Geologists call this area with softened rocks the asthenosphere. A means without, sthenos means strength. The asthenosphere has rock without strength because it's weakened by heat. The asthenosphere belongs to a layer of Earth called the upper mantle. Below the asthenosphere, the upper mantle gradually hardens into solid rock. The hard portion of the upper mantle and the stiff crust above are held together like a jelly sandwich by the gooey rock of the asthenosphere in between. Maybe by now you've given up plans to get a shovel. Fortunately, curious geologists have figured out what's down there without digging. One tool they've used a lot instead of a shovel is the seismograph, which records the energy waves of earthquakes. Seismographs reveal that right below the upper mantle lies another layer of rock, the lower mantle. The lower mantle carries earthquake shock waves in a different way than the upper mantle, and this shows up on seismographs. An earthquake here gives different kinds of readings to seismographs here and here. The difference between upper mantle and lower mantle rock is mostly caused by one thing: pressure. The weight of the crust in upper mantle presses down on the lower mantle. Gravity pulls everything to Earth's center. Below the line dividing the upper and lower mantles, a sudden change takes place. Like water changing to ice because of cold, lower mantle rock changes form because of pressure.
Where's my notes? All right, so have you seen this before? And it seems to be gone. So with the new software, it didn't convert some of the stuff. All right, so this is what you need to know for the outer core. All right, so the outer core is made up of, so go ahead and type this in as I'm saying it. It's made up of iron and nickel. Probably should check yours.
Well, I've been using the Google Slide one, so it's different.
Is there anything on your slides? It is made up of iron and nickel. It is the only truly liquid layer. So this is at the point of the Earth now where we're not dealing with rock anymore, right? The crust and the mantle made up of rock. Now we're into the core, which is made up completely of metal. All right, so the only things you really need to know about the outer core, the only truly liquid layer, it is made up of iron and nickel. It's gone on yours too? All right, so the inner core, whoops, let me go back. Nope, too far. Don't tell me these things are there. So again, the inner core, smallest, the crust is the thinnest of the layers, but this would be the second smallest. But it's still the size of the moon. It's also as hot as the surface of the sun. And I can't see the writing, so I'm having trouble clicking on it, finding it. Yeah, you would think. Sorry, guys. There we go. Why does it keep switching slides? There we go. I think since it's the same company that it would
Do it all transfer, yeah.
do all transfer. Nope.
Do it right, yeah, using those.
All right, so I'm going to make a change on the homework. We have 10 minutes left in class, so I'm going to delete the worksheet. So what you're going to do is finish the activity that we're going to start in the next couple minutes. And you guys have a lot to do because you have to watch 2 days of videos and do the assignments that were posted also for those days. All right, so again, the inner core is a solid ball of metal. Now, if the outer core is liquid and the inner core is hotter, then why isn't it a liquid? Why is it a solid all the way at the center of the planet when that's the hottest part of the planet? Shouldn't technically the metal melt if it's already liquid in the outer core? Does anybody know why it's solid? Okay, you should. You watched the video. It is solid because of the high pressures. Those pressures will not allow anything to exist as a liquid. All right, so I want to go over the assignment really quickly. Are we done with this slide? Yes? Okay. So you can see here that I posted Earth Layers worksheet. I'm going to go ahead and delete that now. So now you see where it says Earth class layer assignment, layers class assignment. This is what it is. So you have a few slides here. For each slide, it's telling you what to do. So you're going to drag these boxes over from highest temp all the way down to lowest temperature. All right, for the layers. You're going to do the same thing with pressure. You're going to do the same thing with density. And you're going to do the same thing according to the thickness of the layer. Okay? Here, pull the proper layer up to its consistency, what state of matter it is. Is it a solid, liquid, or semi-solid? Last slide is analysis questions. So again, this is going to be your homework. You'll start now. What time is it? So you got 6-7 minutes left in the class. You'll start it now, but you're going to finish it for homework, okay? So the original homework I had, I'm going to go ahead and take that off, and then it will be just to finish this. Does anybody have any questions on anything we covered today? So my suggestion for you, so you're not overwhelmed, is just watch one of the videos tonight. Watch Tuesday's video, because that's the shortest one, and then you're responsible for over the weekend for watching the second video.